Yes, thank you very much, and thanks to the organizer for inviting me to the forum. So I would like to start my presentation by doing a small survey. So who among you, if you can raise your hand, who among you have heard about Copernicus European program vaguely? Yeah, I would say a third, so that's not too bad. And who have heard quite extensively about Copernicus already? One or two. So yes, so I think the purpose of this presentation is very useful to try bring you some of the gist of the Copernicus program. Of course, within this presentation, I won't have time really to show you all the wealth of information and potential that there is within Copernicus, but I hope that will give you appetite to go and look in the different website of the program. Okay, so what is Copernicus? So first, Copernicus is what Europe calls a flagship program for its space policy. The other flagship program is Galileo, you know, on global positioning. And Galileo and Copernicus are the two programs of the European Union in matter of space. So the objectives, there are three main objectives. The first one is to monitor the Earth, the environment, and ecosystems. So the program, the idea for the program actually was born just after Kyoto. So just after Kyoto, groups of people started thinking that it's good to have international agreement, but it's even better to have a sound basis to see if progress is made. So that's the first pillar. Second pillar is to increase preparedness for crisis, security risk, disasters, and the final one, which is also very important, is contribute to a real ambition for the European Union to be a global player. A very important principle for Copernicus is all Copernicus is full, free, and open data. So there's nothing in Copernicus which is restricted. We had the talk from Olivier Bousquet on the Sentinel data. This is free and open. This is for everybody in Europe, but also in the world, and that's a very central element in the program. And finally, one objective of Copernicus, which really took form after the crisis in 2008 and 2009, is that Copernicus, with this open data policy, should be really a tool for economic development based on the digital economy, based on knowledge about the environment. So with these keywords, I think you have the panorama for what is Copernicus as a program and what are the ambitions of the European Union. So for this to happen, of course, you need serious money. So the program started relatively small with a number of research projects, preparatory actions, etc., starting to build, design some satellites. And now we are in a phase between 2014 and 2020 where there is a very substantial funding, above 4 billion euros, which is invested in this Copernicus program. Most of this money goes into the Sentinel program, so the satellites, but also a sizable fraction goes into services, because as part of the Copernicus concept, of course, the satellite images are not the answer to many of the questions. So you need something in between, models, other observations, to bring information to the public, or to bring information to companies that will be able to develop using this information. So the governance is fairly simple. So the European Commission is managing the program. The European Space Agency and EUMETSAT are managing the space segment, so the spacecraft. There are 6 services which are grouped thematically, and most of my presentation actually will be on these. Each of these services are implemented by a so-called interested entity, and my organization, ECMWF, is running the Atmosphere Monitoring Service and the Climate Change Service. And finally, there is a component which is about in situ observation, which is relatively small in terms of funding, but is very big because actually it builds upon a large number of research activities, actions, or measurements that the member states in Europe are doing. Something key in Copernicus is that nothing in Copernicus is done without the users. And the users are really key to really decide what will be in Copernicus, what will not be in Copernicus, what will the satellite look like, what will the services look like. And this is a real exercise. We've we are just in the process of completing discussions for the next generation of Sentinels, and this has been a very open discussion with dozens of workshops to decide what would be the next Sentinels. So the user requirements actually feed into all the components of the services, and in the end, it's the uptake by the users and the economic value which is built, which is the measure of the success of Copernicus. So Copernicus is first the Sentinel family of satellite. So Olivier Bousquet mentioned Sentinel-1 and Sentinel-3, but actually it's a family. Well, the family has 6 members, and each of the members of the family has several satellites. The objective, all these satellites have a different characteristic, have different aims in terms of the geophysical parameter that they measure, but they share a commonality, which is to have an operational capability. That is, it's not just a one-off, a satellite that goes and gives some data. The idea is that one satellite goes, and then the next one is ready before the end of its lifetime to take over, etc. So it's exactly the same scheme as we have for meteorology. So the Sentinels are bringing really Europe and the entire world with an operational capability. So, of course, with all these satellites, there are lots of very nice images that you can see. So I selected these because they are very beautiful, but they are also connected with scientific topics. So you see a very intriguing algae bloom, where you see how the algae develop within the dynamical structures of the ocean. You see a picture in false color of the Po Valley. You see all that you can do in terms of land use and land use monitoring. And of course, you see this striking image from the Piton de la Fournaise, which was taken last year, actually, by Sentinel-2. So there are lots of images. You can access all of these. But beyond that, in Copernicus, so you have the in situ observations. So in situ in Copernicus is whatever is not from satellite. So it can be actually remote sensing from the ground, ground-based, aircraft, sea, etc. And in situ observations are really critical to Copernicus, because it's the quasi-unique source of reliable validation and calibration for many of the products. And what the user demands is really to know about the quality of the products. And without in situ observations, we will not be able to respond. Most of my talk will be now on the Copernicus services. So as I said, they are grouped thematically, and there are 6 of them, and I will jog through the 6 services and spend a little more time on a few examples. So the first service I would like to mention is the land monitoring service. So this land monitoring service is looking at all the aspects relative to land use at the global scale, with higher resolution over Europe, but Europe includes, of course, La Réunion or La Martinique, La Guadeloupe. So this is higher resolution product with a number of layers being available, and then even a local dimension. So these are used for lots of applications. So if you go to the land.copernicus.eu website, you can retrieve data. So I took this from Réunion Island. You have a digital elevation model. You have land cover maps. You see that these maps date back before the start of Copernicus. That was part of the Corinne Land Cover program. But what Copernicus brings to Corinne Land Cover is actually a more frequent refresh. So in the past was every 6 years. Now will be every 2 to 3 years. So doubling the frequency of update. And also I learned from the colleague at the EEA that they try to capture both Saint-Denis and Saint-Paul, because it's over 100,000 inhabitants, but 2 times the acquisition failed because of clouds. So they will keep doing, and normally there will be an urban atlas also for the 2 cities. So you have lots of interesting products that can interest lots of scientific areas. So I took there some of the surface characteristics for the year 2012. You see different type of information, wetlands, permanent water bodies, or this parameter which is quite interesting, which is imperviousness. So it's qualifying the grounds where water is not penetrating. So you see the cities and you see the areas where there is lava. Sorry. So Copernicus has also a very important marine environment service. So I didn't select products from this service today, but you have lots of information about the ocean, the dynamical part of the ocean, but also all the biogeochemistry, ocean color, etc. Atmosphere monitoring service. So I will spend a little more time because this is the service that I'm in charge. So it deals with all of atmospheric composition, ranging from the question of air quality, forcing to climate, greenhouse gases, ozone layer, UV radiation, solar radiation, and finally emission fluxes and fires, for instance. So the way the atmosphere monitoring service works is very similar to the way weather forecast work. So we use a number of satellite observations that are assimilated in our global system that we run at ECMWF. This provides a number of products. I will show you some examples. And then over Europe, this time it's the continental Europe, we have a high resolution ensemble of models that deliver air quality applications. And all these information are provided free of charge to national agencies, SMEs, citizen scientists, everybody, actually. So if you want to have a look, you can go to atmosphere.copernicus.eu, and especially the maps section. This is the type of information that you will see. You will see real-time analysis and forecast, just like for the weather, except it's for most or all the relevant atmospheric composition parameters, from aerosol to greenhouse gases like CO2. And these products are done using modeling, assimilation of satellite observation, as far as some exist, and then we have an extensive program of evaluation of this product. And something I will not discuss today is that we are doing a specialized reanalysis of atmospheric composition. Adrian Simmons will discuss the meteorological reanalysis, and we do something similar except on a shorter period and focusing on many of the atmospheric constituents. So part of what the service can do is to monitor what's going on in the atmosphere. So currently we are experiencing the ozone hole. You can see on these graphics, but Adrian Simmons will talk a little more, that this year is actually marked with a very small ozone hole. It's actually in recent decades the smallest, except for 2002, when there was a vortex split. And we can link that to an anomaly, high temperature anomaly in the stratosphere that actually was very well captured even in seasonal forecast. But Adrian will talk a little more about this. And of course, Copernicus is not only for science, so it's nice to monitor the ozone hole. It's nice to be able to monitor the ozone layer, but it's even better to make it up to the end user application. And this is an example which I took from the Bureau of Meteorology in Australia, who has surveyed the UV index and UV index forecasts that were available globally, and selected our Copernicus product to deliver UV index information in Australia. And so today, if you go in Australia, the information you get on smartphones comes actually from the European Copernicus program. The Atmosphere Monitoring Service has also a range of air quality products which focus on the European domain. It's not only air quality pollutants, it's also pollen, which is something that we've been developing for some years. Here also the driving force has been a request from the users. A quarter of the population is actually sensitive to pollen, and that's why we went into that direction. And an example of application is this application for London, where you see that the relatively coarse information that we provide over Europe with a resolution of 10 by 10 kilometers can be downscaled to an urban forecast with the modeling of the local sources being blended with the larger scale information. And this has been replicated now in lots of places and can be done also over La Réunion, I guess. Let me move now to the fourth service, which is the climate change service. So this service has a very big ambition, which is to be Europe's climate gateway, provide information on the essential climate variables, provide information on the past climate, and this is where the reanalysis is essential, and also provide access to, or improve access to seasonal forecast and climate projections. So I won't go into detail on this one, but this is recognizing that the different levels of users need a different interface with the data. You have developers or scientists who are able to crunch a massive amount of data, but this is only a small fraction of the users, while you need for the end users, the general public or the media, a very simple interface where you see only the surface of things. And so part of the Copernicus climate change service, we are building a so-called climate data store, which is designed to make this happen. Let me now take an example of one of the products of the climate change service, which is the seasonal forecast. So seasonal forecasts have been around for 2 decades, I think, but within the climate change service, there is augmented ambitions in terms of operationality and in terms of quality of these forecasts. So this is done by combining European effort on seasonal forecast, but also by joining forces with US, Japan, Canada on this topic. And what does the Copernicus Climate Change Service is to deliver every 15 of the months a 6 months outlook on the weather. So this is the current example, which was released a couple of weeks ago. This is a forecast for this November, December, January. And as you can see, for La Réunion area, what is expected is 80 to 90% chances of being hotter than median, and 70 to 80% chances of being wetter than median. So we'll see if it is right or wrong. Actually, looking at the past, the Réunion Island is relatively well situated for seasonal forecasts because in the tropical area, the skill of the individual models that are fed into the Copernicus system is relatively better than at extratropics, and so so the quality can be actually quite good in the El Niño regions, which you can see in dark red. The predictability at the seasonal time scale is really excellent, and within the ocean, the Indian Ocean, it's not too bad in terms of forecast. So you can check these. I will not talk about the climate reanalysis. This is the crown jewel of the climate change service products. Let me move rapidly to the final set of services. One is very important on emergencies. So this service provides both rapid mapping but also forecast. In terms of rapid mapping in the Indian Ocean area, actually since 4 years it has only been activated 2 times, so this is a relatively good sign, but maybe also a sign that it is not activated enough. The 2 examples are actually in Madagascar, and one was a flooding, and the other one, for which I have an image, was an accidental release. So Copernicus is capable of delivering extremely high resolution images, showing the situation, and in many cases, showing the situation as it was before to assess the damages and help with the emergencies and reconstruction. The other aspect of the emergency program, which may be of interest for you, are forecasts of the fire danger in particular. So this is the current forecast, which I took Saturday or Sunday, and this is the forecast for today. You see in shades of color the risk of fire. So it's, of course, much more severe in Madagascar at this period. And you see there are regions where danger is rated as extreme. And by the way, you can also see from satellite measurements where fires have been active. So you see here the picture of Madagascar. I don't know if it's very visible on the screen, but the small dots are all active fires. And you can even get information on the emissions that are emitted by this fire. So this is the plot on the bottom. So you can get emissions from CO2, black carbon, etc., that can feed into numerical models to forecast the impact on Réunion Island, for instance. Finally, the last service is about security, and this is covering many aspects of security on land, but also on sea, and this is supporting in support also of EU external action. So the final slides for my talk are about communications and media. So as I saw in my small survey, the knowledge in the general public or even in the specialist public about Copernicus is fairly limited. So we are on a trend to increase that. So you can see an increasing number of media picking up Copernicus information whenever there is something related to environment and climate. So this is a good trend, and this is very important because in the end, Copernicus costs about 1.5 euro to every citizen per year, so it must be known. So that's the first thing. The other thing is, of course, to have a solid socio-economic impact evaluation, and this is what is currently being done, and PwC has made a study about the economic impact of Copernicus. And just a small result is that so far, since the inception, Copernicus has cost about 7.4 billion euro to European citizens, and it is estimated that until 2020, the return on investment will be of the order of 13.5 billion, so a doubling. And in their study, what they show is that they expect over the total period a factor of 4 to 10 benefit to cost through the program, and they have a very detailed assessment on the impacts in different socioeconomic areas and for the different services. Thank you very much.